Alright, we're back on the project. We are ready to take the next step to get this thing put back together. This is my second attempt at ordering the seals for this. This was the first set that I had ordered. And they're not even close to right. You can see old and new there. So my second attempt, this is the one that I got. And that looks a lot better. So, of course, these were about 5 times as expensive as the wrong ones, but it doesn't make much difference if these are the ones that I need. So I'm going to go ahead and get those oil seals pressed into place in the axle tubes there, and I'll show you a tool that I've made here to try and do that. I've used a tool like this a couple of times before for this job. Essentially all this is a piece of threaded rod, in this case 1/2 inch, with a couple of nuts on the inside, and then I've taken a stack of washers, stacked them up until that largest washer was about the same diameter as the seal, and then I just tacked them together with my welder. Tacked them on the inside there. If you don't have a welder, you should get one. I suppose you could do this without welding those washers together, but if welders are not that expensive, it's really a good investment, especially if you're going to be doing a lot of your own mechanical work. The ability to join steel is a powerful force multiplier, and amongst other things, it allows you to build some of your own tooling. So this is what I'll use for that. This one's longer than it would need to be. This was just a piece of threaded rod that I had laying around. You can cut that off if you don't want to wrestle with it. But essentially what this will do is it'll go in there in place of the carrier and slide up in this way. Try that again. Slide up in this way. It'll fit between those faces there where the seals are installed, and then you just run the nuts apart and use it to press the seals in place. Especially with a seal like this, it's a multi-piece seal. It's got kind of that shielding on the outside there. I don't like to beat on those with a hammer. A lot of times with a regular oil seal, you can tap them into place gently with a hammer. You can be real careful and go around the outside and make sure that you don't mess things up. But this is a much more controlled means of getting those into place. So I think I've got everything I need here now to start putting this guy back together. So I'm going to go ahead and do that. Let's get these seals put into place. There we go. Got our new seals in place. One thing I like about using a threaded tool like that and hand tools is that you can kind of feel how tight things are getting. You can kind of feel the tension in the tools as you're putting things together. Those seals moved into place fairly easily, and I could feel them bottom out. They just kind of stopped moving all at once. And that's a touch, that's a feel that you don't necessarily get with power tools or with a hammer. So anytime you're installing a seal or something like that that is somewhat critical, reach for the hand tools and not the power tools. So with that, I think we're about ready to start getting some things cleaned up here and get this guy ready to go back together. I got to clean that housing out, we'll get all the gunk out of there, We got to get that all cleaned up, and then clean up the mating surfaces there for our silicone. Get those cleaned up as well, and then put this guy back together. I like to use a powered wire brush on a grinder if I can to clean these surfaces up. It does a real good job of removing the silicone and doesn't mar the surface, doesn't create any you know, ribs or scratches that are likely to cause a leak down the road. So I'll probably go ahead and work on that. I'll probably do that off camera. Afraid this video is going to get awfully long here if I film the entire process. So I'm going to go ahead and get this cleaned up. I'll bring you back in here once we're ready for the next step. All right, I've got everything cleaned up here, so I think we're ready to go ahead and put this guy back together. I went ahead and clean these faces up. I like to use a knotted wire wheel and a grinder, or if you've got a wire wheel on a drill, that'll work as well. It's not quite as fast. I did go ahead and stuff some rags up in here to try and keep the little bits of silicone from flinging their way up into places where they shouldn't be. I guess a word on cleanliness when it comes to this sort of thing is take the time and get it as clean as you possibly can before you reassemble it. This differential is kind of like that indiscriminate friend of yours. There's no filter. So any dirt that you leave inside of here is just going to float around in that oil until the next time that you change the oil. So take the time, get it all clean. I've wiped it out real good. Got all the old oil out that I could, and then kind of hosed it down with some solvent. Just part of a can of brake clean is what I spent on this one. Got it all cleaned out, wiped it out again, and I think we're ready to go back together. So at this point, I'm going to go ahead and get the differential back up here into place. We'll try and hold those bearing races in place while we get it slipped in there. And then we'll be ready to torque the bearing caps down to 85 foot-pounds. 85 foot-pounds is what those receive. So let's go ahead and do that. We'll get this guy back into place, ready to be buttoned up. Alright, there we go. We've got the carrier in place. Got the bearing caps tightened down to 85 foot-pounds per the torque spec. Our next step is going to be to try and clean these axle tubes out. Gunk and rust and dirt and grease and all sorts of nasty stuff tends to accumulate inside there. So we want to clean that out, because invariably as you're sliding those axle shafts back into place, it's going to pick up some of that junk and it'll end up in here again where we don't want it. So we'll go ahead and do that next and be one step closer to buttoning this guy up. Well, there's the result of cleaning out the short side, or the driver's side tube of the Dana 60. This is my little axle tube hoe. No, that's not something the dog left behind. That's the result of dirt, and gear oil. Kind of looks like grease. So that's that side. All this tube is, or I'm sorry, all this tool is about a 48-inch long piece of threaded rod with a washer and 2 nuts on the end. And I use that to reach back inside the tube and just kind of hoe out any of the dirt that was stuck inside the tube there. Just kind of scrape it back out the axle tube end. Obviously, you've got to be careful. At this point, I've already got the seals installed. I probably should have done this before I put the seals in and reinstall the carrier. But if we're careful here, I think we'll be okay. So you just want to reach in until you just touch that seal and then set that washer down in the bottom of the tube and scrape all that junk out. So, I don't know. Let's see. Let me say we try this side. I'll see if I can do it one-handed. Go in about halfway here. Yeah. That's what we're getting. Nastiness. That's gross. So, you see I'm trying to hold that off of the bottom of the tube so I'm not pushing a bunch of junk in front of it. Okay, there's the seal. So now I set it down against the bottom and just dredge that junk out. This one actually wasn't as bad as the other side. Some of these axles have an outer seal on them as well. There's a seal that actually goes in this end of the tube. There's kind of mixed opinions about whether or not it's needed or if it's even beneficial. Some guys say that the only purpose it serves is to actually trap dust and dirt and rocks and debris inside that axle tube. So generally when I work on these, I don't replace that outer seal. They just seem to get packed full of dust and dirt, and that's kind of a tough spot for a seal to live right there anyway. They take a beating, and then once they go, they just hold the dirt inside. So I tend not to replace them. But we got this thing cleaned out. I'll go ahead and clean off the ends of the axle shaft, and we'll slide them back into place here. See if we can't keep maintain a little bit of momentum here and keep this project moving. All right, progress. We've got the axle shafts in place here now. They are stubbed through on both sides. And I think before I put the cover on there, I want to go ahead and bolt the spindles up just to make sure that those shafts are in far enough and that I don't run into any issues there. So I'm going to go ahead and put those spindles in place, and we'll go ahead and bolt them to the knuckle. A couple of notes here. 65 foot-pounds is the torque for those spindle attachment bolts, or the nuts that go on these bolts. So 65 foot-pounds is what all 5 of those will get on both sides. The other thing is make sure these faces are clean. See, this one's got some junk on it here. You want to make sure that that's all cleaned up. And since these also kind of capture that dust shield, that the dust shield goes on here and then the spindle goes on top of it, you want to make sure that all those faces are clean. If you get a big chunk of dirt or a thick piece of slag or rust or something in the way here, it'll throw off the alignment of that spindle, which in turn throws off your alignment. So make sure this is all cleaned up. Make sure everything here is in good shape. Make sure it's clean and flat. I'm going to go ahead and just clean those surfaces up just a little bit with a scraper. Make sure that everything's in good shape, and then we'll go ahead and get these spindles bolted back in place. Hey, so a note real quickly about bearings. You're probably aware you've got 2 wheel bearings that go on the outside of the spindle here. There's a third bearing on the inside here, and the purpose of that bearing is simply to carry the shaft, carry the end of the axle shaft. So if you think about it, when your 4-wheel drive is disengaged, that shaft is not turning. It's stationary. But when it's engaged, it's spinning, and something needs to be able to support this outside end. And that's what this inner bearing for here. That's what that is for. So make sure that that bearing is in good shape. Make sure it's there. I've seen trucks before where That bearing wasn't even in there, and the end of this shaft was simply supported by the lockout hub. And that'll wear things out in a hurry. So make sure that guy's in place, make sure it's in good shape, make sure that those little rollers move. And then carry on. Making some progress here. Axle shafts are in, spindles are bolted up and torqued. Went ahead and cleaned all those surfaces up, smeared the cover up good with ultra black RTV silicone. Went ahead and put it on there, just put the bolts in wrench tight and let it set for a few minutes to let that RTV take an initial set, and then I went ahead and torqued those bolts to 35 foot-pounds, which is essentially wrench tight. It's not real tight. So at that point, I think I'm going to go ahead and we'll bolt up this tie rod end again and put that part back together. And then I think we are ready to start thinking about putting spindles back on here as well. So I think we may go ahead and try to do that as well. It's raining a little bit here now, but it's just a gentle rain, and I'd like to keep making some progress here, so I think we're going to keep going. We'll try and dry the tools off later. So what do you say? Let's get to work and make some progress. Alright, we've got the hub sitting back in place on the spindle there. I didn't worry about re-greasing these bearings. The grease in there looked really clean. There was a lot of it, so I'm not going to go to the trouble of re-greasing those right now. We went ahead and installed a new cotter pin on the castle nut there for our tie rod. Those are important, guys. Put that back. If that nut backs off, your truck's not going to go where you point it. So that's what that cotter pin is there for. It's just to keep everything tight. So I want to go over one more time the way that these nuts work, because it's not super intuitive if you haven't worked on this before. This is the inner nut, and I can tell that because it has that little point on it. And there's three pieces to the way that this system works. So there's that inner nut. Lay this on a rag. There's that inner nut, and then there's this locking ring that fits over that little point. And if you notice, the holes in this locking ring are not indexed the same. See how they are in relation to this tang? That tang goes in a little flat in the top of the spindle. You can see it right there on the top. That keeps this from being able to turn. So what we're going to want to do is tighten this up. Most guys will say either make it wrench tight on this nut to seat the bearings and make sure that everything is tight. I tend to kind of spin things as I'm doing that, kind of roll everything into place and then tighten that down, and when you get that good and tight, you will not be able to turn this. The bearings will be too tight. Now don't go crazy. You don't need to go nuts. You'll end up hurting bearings and breaking things. But you want to tighten that down far enough that you're making sure that those wheel bearings are seated, and then you back it off until you can turn it, not completely freely, but until it turns comfortably by hand. You don't want a ton of resistance in there, but you don't want to be able to just fling it either, because you'll notice that you've got some wobble in it, okay? So this nut goes first, this guy goes on, and wherever that point ends up, you can flip this thing one way or the other. See how there's a hole farther away from the tang there than it is here? So it gives you kind of a half step between those holes locations. So you can kind of flip this thing to get it as close as you need to. Depending on how tight your bearing is, you might have to tighten this just slightly or loosen it just slightly to make everything line up. And then this guy goes on top and receives the torque to lock everything down. So with that in mind, I'm going to go ahead and put these three nuts, or these three pieces of this lock nut system, back into place. And I'll bring you back here once we've got that all accomplished. All right, I've got the inner nut in place, and I've got the lock washer in place, the locking ring, and I want to show you what that looks like. So if you see right here at kind of the 11 o'clock position, you can tell that that hole, get the light just right, has the locking pin sticking into the locking ring. Now with that outer nut tightened against the locking ring, that inner nut cannot back off. Right now I've got about 50 foot-pounds of torque on that interior lock nut. And I can spin it easily by hand. There's some resistance there, and there should be, because you don't want those bearings loose. So I've got that inner one in place, torque to around 50. I had to fiddle with it to get it to line up, but now that I've used a flashlight and I'm absolutely sure that I've got that pin into one of the indexing holes in that lock ring, I'll go ahead and put that outside nut on. Now there's some conflicting information out there on how tight that nut should be. Some people say 50-60 pounds of torque is all that it takes to actually lock this thing down and you'll be good to go. That doesn't seem like nearly enough to me, and the other specs that I see out there are anywhere from 125 to 140, some even 160 pounds. So I tend to err on the side of making this outer nut as tight as I can make it. Those are some big threads. I'm not really worried that I'm going to turn those, spin them off of there, or break that nut. So I tend to really put a lot of torque into tightening that down. Go ahead and torque it to 140, 160 foot-pounds. So I'm going to go ahead and torque that up now. Then we'll put the locking hub back into place, and this side will be done. I don't think I'm going to show you the other side. The other side's got a couple of broken wheel studs in it that I need to replace anyway. If you ever need to do those, you can just knock them out with a big hammer. Either if they're still in there, you can whack them right on the end with a big hammer. You know, sit this on the concrete or on something hard, you can knock them out, or if you have to get in there with a punch and drive those out, and then the new ones just pull in with pressure from the nut. So that's what I'll do on that to get those wheel studs replaced, and then the other side can go back together as well. So let me go ahead and torque this outer lock nut, then we'll put our locking hub in place. Okay, outer lock nut is torqued to 140 foot-pounds. I can still spin the hub by hand. I give it a good shake. I feel no free play. There should not be any slop in those bearings. It should be tight, but you should be able to spin it by hand. So at that point, I think we're in good shape. We can go ahead and put our locking hub back in place. So I don't know if you've ever seen one of these locking hubs before. This is the OEM Ford piece. I think the Warren ones are pretty similar. Essentially what you've got is this outer spline is locked to the wheel hub. This inner spline is locked to your axle shaft. And the only thing that locks them together is this ring right here. So it slips. Sorry, I didn't have you in the shot, did I? It's this ring right here. So this is free. Once this is pressed in, if I can get the teeth to line up, then everything else is locked together. And essentially that outer knob that you turn, all it does is it's on a real aggressive thread, so that when you turn it, if I can do it with one hand here, yeah, I can't. There we go. Can you see that move in and out? You can actually see the threads there. So all it does when you turn that is it pushes this ring into place. Locked, free. So I like to just throw one of the screws in here and just run it in by hand. That gives me a little bit of a handle to hang on to. Kind of wiggle things around to get that axle lined up, and it should slip right into place. Once it is in place, then your locking ring goes in. And these can be a little bit of a challenge. I tend to like to use a couple of screwdrivers to get them into place. You kind of start one end of it and then work your way around, and you can spring that guy into place. So I'll go ahead and do that now. And then all we have left is that outer locking hub. Alright, well, the weather has continued to deteriorate. It's turned into a great day to be a duck. But we've made some progress here nonetheless. You can see I've got the locking hub back together. The hub is in place. Everything's torqued down. Spins nice and freely. We've got our cover in place. The bolt's torqued. Got the passenger side reassembled as well. I'm not going to go ahead and put the calipers and the brakes back together right now. I've got some work yet to do to those. Those are going to get new brake hoses, and I'll probably leave the wheels off until I can get all of my lines and things connected and get those calipers bled. But that is largely it for what is involved in changing those seals, save the fact that we still have to put some oil in it. I typically, if I can, I like to let that RTV sit overnight or 24 hours if I can before I flood it with oil. It would probably be okay, but I like to let it set up if I can. So I've still yet to fill this guy up with, it takes almost 3 full quarts of gear oil to fill a Dana 60 front. You can use whatever you like. I tend to use 80, 90. Some guys will say you need to use synthetic fluid, that you should use 75, 90, full synthetic in these. I tend to err on the side of using a little bit cheaper oil and just changing it a little more often, especially since we may have a opportunity to get in there and kind of refresh this and empty out any of that dirt that may have gotten in while we were doing this service. But that is it at this point. We are done with our seal replacement. This guy is ready to go back together. So if you're enjoying this series, if you want to see more on these OBS trucks, subscribe to the channel. I'm spending a lot of time and energy right now working on this project and that truck and my other truck. Spent a lot of time on these OBS diesels. I'll try to keep breaking things down here and doing some of these how-to videos, and we'll try and get as much of this caught on video as we can as we make progress on this truck. This truck also is going to be for sale at the completion of reassembly. So once this thing is all put back together, all the kinks are ironed out, all the bugs worked out, this truck will be for sale. So if you are near Northeast Ohio and you're looking for a truck like this, let me know. I would entertain the notion of working out a deal with the future buyer to allow them to kind of determine the direction of some of these decisions. You know, we've been talking for a while about whether we flatbed this, whether it gets a dually bed on it. You know, I'm planning on putting this back together stock. But I'm certainly open to input, especially if I have an agreement and a relationship with the person who's going to be driving this thing when we're all finished. So if you're interested, post up in the comments down below. I will get in touch with you here. I'd love to talk with you. But at any rate, that's it for the seal replacement on this truck. Thanks for watching.